Hey guys, we are glad to introduce our research product, iLens. It is an augmented reality contact lens integrated with real-time facial recognition, which can show AR contents on top of the real world and enable users to see AR face profiles. At first, let's have a quick look at the current related work. The Sony company has a patent about the AR contact lens, which is very similar to our design. But we have more sensors such as thermal cameras, and this is an imagined design of our research product. The face recognition technique we used here is based on convolutional neural network, as known as CNN, a famous deep learning approach. The current ROC evaluation shows that the deep learning method has reached the same level as human beings in face recognition. But in our product, we improved the accuracy by adding many other useful features.
So the blockchain part tries to solve the security problem of traditional centralized systems. There are so many attacks that happen to this system, and every time users' personal data was either stolen or sabotaged by attackers. But in a blockchain, the original data is separated into thousands of pieces and they are spread across the global network. Now each piece is sent or to say encrypted by the owner's secret key, so no one else can alter or read the data without owner's consent. This is called a distributed file system, for example, the IPFS. Actually, blockchain is more than a secure database. The essence of a blockchain is in its consensus mechanism. In this case, it's how we agree upon one's identity. Imagine it's the first day you go to work for your company. How do you know the first person you met is a manager or just a staff member like you? I think anyone with minimum social experience can tell from others' attitudes towards that person. So here, we use everyone's recognized as an indicator of the authenticity of one's identity. And the value can be shown as a token called trust coin. So basically, you can receive trust coins when you are recognized by another person. As a result, we can judge one's reliability by how many coins he got in total. For specialists, like we want to know whether a person is an employee of a company, because every verification is recorded in the chain. We can always go back to check whether the company's identity has verified that person. Let's say a company can also have an identity and is publicly known to everybody. We can build on our project upon the open source project Sovereign, which is self-sovereign identity system.
Have you encountered to a police and scared of somehow they give you a fine? But have you ever thought of this situation? Fake police is becoming one of the concerns to the community because civilian is afraid of the penalty of annoying real police, but also scaring of under the dangers of fake police. One said real police will have an identification document. However, this is not easy for normal civilian to classify if the ID is true or not. It is also not easy for the civilian to make the decision in a short period of responding time. Alright, let's put us into a real-life example with the use of our iLens. Imagine you were driving on a highway and the police waved a hand signaling you to stop your car. So you drive nearby and see what's going on. Before you bring down your car window for a further investigation, you can look through the identity of the police by checking if his police identify document is verified by the government, so that you can make your decision to either reject his instruction and start calling the real police to catch this criminal, or you can just follow his instruction if he's the real police.
This is a pipeline showing how the face detection and recognition works. First, look at a picture and find all the faces in it. Second, we transform the images by finding out specific landmarks on the faces to make sure that eyes and mouth are in the center. Then, we need to extract feature measurements from the detected face, such as the size of the mouth or the space between the eyebrows. Finally, compare the unique features of that face to all the people we already know to determine who the person is.
In order to evaluate our iLens product, we had gone through several tests to evaluate the functionality of it. We have invited 200 candidates and left half of them wearing iLens in a room and the other half in another room without it. In the first test, we left them in the room for half an hour and asked them who they recorded in the past half an hour. We discovered that the iLens group record more people than the other room, and most of them are found to have similar interests. The first test, our iLenses have shown we have reduced the time needed for strangers to starting interacting to each other. For our second test, we asked some candidates to change their age to a fake age on the profile, and we asked one new candidate to identify who is setting the wrong age by giving him a special version of iLens with functionality to force showing real age. For privacy reasons, this version of iLens is only provided to government and is issued by them to legal registered places that require a proof of age, such as casino, alcohol store, or maybe nightclub. In our third test, we separated the iLens room into 4 groups and asked them to set up identity in the iLens profile as one of the group name is their identity. We then asked them to put a group name label on their shirt, with half of them putting the wrong group name on the label. We now let the candidates in another room to wear iLens and ask each of them to identify which group member is each candidate assigned to. In our third test, we separated the iLens room into 4 groups and asked them to set up identity in the iLens profile. We then asked them to put a group name label on their shirts, with half of them putting the wrong group name on the label. We now let the candidates in the other room to wear iLenses and asked each of them to identify which group is each candidate assigned to. All the candidates has successfully put all the candidates back to their actual group, which show the sensitivity of iLens is high enough to identify one's identity. For our last test, we secretly put up an image of a person which does not have facial data in the database and an image of a dog on the server, and we invite each candidate to go into a room with 4 people and 4 dogs, in where the person and the dog in the image are among one of them. Each candidate also successfully automatically saying that the person is a criminal and the dog is a missing dog, which also show the sensitivity of image matching is also high enough for the identity wanted criminal and lost object.
Thanks for your watching. All the things mentioned above is our fictional research, and many fancy ideas mentioned in the research paper, it came from our group discussion and group brainstorming. Although this is a fictional research, many things and techniques mentioned in the paper is very possible to be realized in several years. Okay, thanks again for your watching and hope you will enjoy our product iLens.